finish, excellent mechanical property, hard and durable, and also toxic emission free in a fire environment. And also it will protect the steel structure up to 2 hours. The mechanism of the fire dam 263, as we mentioned, when you apply the coat over the steel structure and then you apply the fire toward the steel structure or toward the paint, the binder will start to melt in the centigrade of 200 centigrade. And then there is an acid donor which exists in the composite of the paint. It will start to decomposite to produce the polyphosphoric acids. And the polyphosphoric acid will start to react with the carbon donor, also which exists in the composite of the paint, and start to form the polyphosphoric acid ester. And later on, the carbon matrix will be produced and it will be produced and swell to delay the heat transfer from the fire source to the steel or the substrate of the steel structure. As you can see here in the picture, the formation of the char step by step start to create until totally expand, and it expands 50% to 60% of the thickness of the DFT, or the dry-film thickness of the paint. And there are blowing agents that release during the fire that also, which is inflammable gases that also control the spread of fire in your property. And also the very important point in the paint is to be adhered strongly to the substrate during the fire. If it will fall down, later on the substrate of the steel will be totally exposed to fire, and the temperature will increase to the critical temperature where the steel loses the design margin of safety. The application of the fire dam 263 can be applied by the air spray, and we can use the brushes for unreachable corners. And the system for the fire dam 263, we have to apply epoxy zinc phosphate primer, and then after that we apply the fire dam 263 according to the demand of the thickness that we have, or the optimum thickness that we have found it, or we discovered from the calculation of the HP/A. And later on, if you need more protection against the aggressive weather or external application, we recommend to use Al-Jazeera Fire Dam 275 as a top coat, and Al-Jazeera 275 is a solvent base, and it can be produced with a variety of colors. And Al-Jazeera 275 also has the property of inflammable. It has the property of a flame spread during the fire. This is the table what I talk about. Here is the HP/A column. Okay, after you calculate the HP/A, the heating parameter over the cross-sectional area, you will start to look for where the HP is located in the table. And this table has received from the underwriter laboratory. And for example, if our HP/A is 41.3, you will go across the table to find out the optimum thickness for your steel structure across the protection time you need. For example, if we need like 1 hour fire protection and our HP/A is 59, we will go across the table, and we will find our thickness, for example, is 1.88 millimeter. And also this is the table for the whole section steel size, and this is the certificate we received it from the underwriter laboratory in 2010 after we have made our test in their laboratory in the US. And also they come or they visit our factory to check the batches of the fire dam 63 and quarterly a year, and this is the form of the inspection they use it in our factory. And also our product, it has been tested as well at the Exoba Fire Research Center in UK, and this is the tables we have received from Exoba for the optimum thickness that needs for every steel size. Those are pictures has been captured during the test of Al Jazeera Fire Dam 263. We, after they applied many items of columns and of beams, they put the columns and beam in a very huge furnace. The temperature started from 200 centigrade until 1,700 centigrade to test the performance of the intumescent paints during the fire. As you can see, this is the shape of this is the column, and this is the shape of the char, which is occurred during the fire. And here we have here we have a small video to show you how it has been recorded during the test. This is the formation of the char during the fire. And there is in every column and every beam, there are 8 for every column and beam, there are 8 thermocouples to measure the temperature of the column or of the item during the test. And this is the test has been done at Wellington and also at the Riker laboratory, and you can see the furnace and the fire that exposed directly to the items and the formation of the char.